Hi, this is Sean, and this is my partner who created the presentation, Jaekyu.
Hi.
And today we're going to talk about avoiding obstacles using potential field theory. So, as an overview, we're going to use a 5 degrees of freedom manipulator, and we're going to pick out an object and transfer it to a desired location that we want, and it's going to avoid any obstacles along its path. So there are many methods to do this, and we actually tried two methods. One is redundant inverse kinematics. We're able to reach the desired position that we want, avoiding obstacles with this method, but there's too many redundant movements, as we're going to show later on. And as for the potential field method, that's what we are using. It's easier to implement, and we're able to avoid singularities and instability easily. So this is how it works. We actually create an attractive force field around the goal that we want and create a repulsive force field around the obstacle. And by doing so, we actually allow the link or manipulator to avoid the obstacle. And so this is a potential field theory that we use, and we also avoided local minima, which is a point where the manipulators get stuck. And so we're going to show you how the redundant inverse kinematic works. So we're going to enter the object location that we want here. And now as you can see, there's lots of redundant movements created by this redundant inverse kinematic system. So we're actually going to use the potential field method, which we're going to show here. And we actually recorded this because our computers are not fast enough to process the simulation. So we're going to fast forward. So we enter the desired point location that we want. And now as you can see here, the blue lines are our links, and this is the obstacle that we want, and this is the desired end position that we want. And so we're going to fast forward this, and as you can see, we are avoiding the obstacle and at the same time reaching the end position that we want. So this is the first part of our simulation, and we're going to do the second part, which we're going to pick out an object. I'm going to specify the object location here, and I'm going to enter the final destination. And now as you can see, this is the object, and this is the end position that we want to achieve, and these are the obstacles. And so we're going to avoid this. As you can see, we're going to pick up the object, and it's going to put it in the desired end position that we want. And now it's another example that uses two obstacle interaction. This is a different endpoint that we want, and this is still the object, the obstacles, and the desired endpoint that we want to go. As you can see, this repulsive motions is created by the potential field method that we actually implemented. And now it picks up the object, and it's gonna be repelled at a certain distance, and then it's gonna go to the end position that we want. So that's our simulation, that's our project, and thank you very much for listening. And this is Sean, and this is Jaekyu.
Thank you.
And thank you for your attention. Bye.